Welcome, my trailblazers. Good morning, trailblazers. I hope you are ready for today's DigiPath Digest.
Learn about the newest digital pathology trends in science and industry, meet the most interesting people in the niche, and gain insights relevant to your own projects. Here is where pathology meets computer science. You are listening to the Digital Pathology Podcast with your host, Dr. Alexandra Zhurov.
As you are joining, I'm going to give you a few updates as always. So I just came back from SITC. Just means last week, last Friday, Saturday, it was SITC. Annual meeting, Society of Immune Therapy in Cancer. So yeah, SITC, Society of Immune Therapy in Cancer. So how I see this area of spatial biology, immunofluorescence, multiplex immunofluorescence is it kind of informs the cancer research, cancer treatment, and future clinical tests, future clinical workflows, which traditionally were then being translated into either IHC or IHC most of the time. But now the complexity increases. So I think they're going to be just native clinical immunofluorescence based tests. And we already have, we work with fish, we work with whatever. I think fish is the most common fluorescent thing that is happening in the diagnostic space. But there's going to be more because we learn more biology. The medicine is more personalized. So that's what SITC was about. So yeah, that's where the field is heading. And so I was there with Hamamatsu and with BioCare. Hamamatsu has this multiplex scanner that scans up to 10 markers. It's called multiplex. And what they did, they have this partnership with BioCare, which is a staining company. They have a stainer, and they're going to be putting together, not only them, but in general, that is a trend, putting together end-to-end workflows for these more complex tests that are based on immunofluorescence, right? That's a little bit more complex than bright field. So you do want to have your partners lined up for each step of the workflow. And one thing that has nothing to do with immuno-oncology that I learned at SITC is that you can rent plants for the conference booth. Did you know that? So Hamamatsu had this bromeliad plant, and I was preparing for a live stream, and I'm like, let me put this plant somewhere. But I'm like, oh, how come they have a plant? Did they bring it from home? No, you can rent it at the conference. I thought that was fantastic. People are brilliant with their business ideas. So you can decorate your booth with plants, and you can just rent them there. Also, another thing that you're going to be getting if you are on my email list, and if you are not, I'm going to give you a chance to do that right now, because you can get on the list when you get the book. So there is a book, Digital Pathology 101, that I'm actively working on updating. But if you get this book through the code, you're going to be on my email list. And the email list is going to get email list gets all kinds of cool stuff that I come up with, but specifically from SITC, you're going to get a recording of the talk. Dr. Carlo Bifulco gave a talk why he also thinks, and that's his work, why he thinks that there's going to be, with the level of personalization of medicine, we are going to go into immunofluorescence as a diagnostic tool. And he did research on that in his lab. And this talk is going to be distributed only to people who are on the email list. So get on the email list if you're not there yet. If you got emails about this live stream, it means you're there, and you probably have the book. But if you don't have it yet, the code is here, and I'm gonna include the code at the end as well. Another thing that I wanted to tell you. Oh, upcoming guests. So we already talked last time that Andrew Janowick is going to be a guest on the podcast. This is already recorded. Then we have one podcast coming up with Victor Angel from Omica.ai. So this company is collecting data from Latin American populations in a responsible, patient-centric way to empower AI development of AI tools that are diverse, that represent populations that are underrepresented, and his story is super powerful. How he came up with this, he also has a personal story to tell, so that's going to be coming up. And today I'm recording with the representatives of Big Picture. Big Picture is a private-public consortium in the US aiming at creating a huge slide repository, like millions of slides for AI model development. And I'm going to be meeting with Jeroen van der Lack and Julie Boisclair, who are leading this thing. And by this thing, I mean this multi-year consortium that had to transform and pivot a little bit as they were, as like transformers, generative AI was being introduced into the space. So these three are coming up. And yeah, book again, let me give you the code one more time. I am committing to updating it before the end of the year. Actually, I have a date. Keep me accountable to this date. On December 1, I'm gonna like rent a co-working space. I'm gonna go to Frederick. I'm gonna rent a co-working space and I'm gonna work on this book. I already did some work with you online as well. So I think 1 to 2 days should be enough, and you're going to be getting the updated version. Whoever already has this version, which the PDF you can download for free through the QR code, is going to get the updated version with a new AI information and like the most up-to-date stuff in the digital pathology space. And now, thank you again for joining me, and let's go to our papers, because I have a few prepared for you today. And we're going to start with a couple of these are reviews. So, you know, in the review abstracts, there's not so much substance, but I still want to mention them because they kind of indicate trends. So, for example, this one, Digital Neuropathology of Neurodegenerative Disorders, Foundation Research Advances and Future Directions. So this is something, this theme topic has been coming up, at least like I've been seeing it. Maybe it's the, what is it called? Reticular activating system. When you start working on something, then you see it all around. So for example, if you buy a yellow car, suddenly yellow Jeep, you see all the yellow Jeeps all around. But because I gave a talk on digital neuropathology in the preclinical space. Now suddenly digital neuropathology papers are showing up after the conference. So one of them is this one from the Emory University, Davis, California, and basically US groups. And what they say here is that neuropathology examination after death remains the gold standard for differentiating between Alzheimer and Alzheimer's disease and Alzheimer's disease related dementias. Like from the diagnostic standpoint, if your gold standard is after death to differentiate something from something else, not really helpful. So, but that's what it is, right? And I have another paper on how to do it actually in life later, which is super cool because it talks about voice biomarkers for Alzheimer's disease. But in this one, this review provides overview of digital pathology technologies and their associated infrastructure, which this is the important thing here, because the questions or the concerns that I've been hearing about neuropathology was like, oh, we're not ready, brain is too complex, brain is like, we miss something. But the papers that are coming out from these neuropathology group consistently tell us, hey, we are there already, it's good enough, we can use digital pathology for neuro, and neuroscience has been doing this for years, right? But obviously research and diagnostic are kind of different from the regulatory perspective, so I totally understand the concerns. But here in this review, they talk about the digital pathology technologies, available open source and proprietary digital pathology software, relevant background of neurodegenerative histopathological features. So I think this is cool also. They mention these histopathological features and computational research. They discuss evidence supporting how recently developed technologies and methodologies can enhance our understanding of histopathologic features of neurodegeneration and correlations of histopathologic features with cognitive performance and age and death. So this is also the correlation of histopathologic features with cognitive performance and age and death. So this is something where once you have like the pairs of data, clinical data and then histopathology data, and if you have it like close to this time when they are performing the neuropathology examination after that, then you may predict one or the other. And here, rather like predict from the clinical, predict the histopathology. That's kind of like telling you, okay, what's going on there. So highlights: historical summary of digital pathology with respect to neuropathology. So all my neuro people, have a look at this one. Key digital pathology technologies that are supporting neuropathology and digital pathology applications in neurodegenerative disease, and also discussing the future of digital neuropathology. So definitely something to look at, especially if you are active in the neuropathology space as a researcher, as a diagnostician, as a vendor, whoever is in there. The next paper that we have is patient safety in AI-powered diagnostic pathology. Patient safety, compliance, privacy, these are the things that come up. Patient safety, right? Patient safety, GDPR compliance in Europe, HIPAA compliance here in the US, and this is a group from Italy. I like when European groups are discussing this because they are Europe-centric. I don't know how to convey that, but often it's kind of more holistic perspective because they have this very strong presence of the American US perspective, and then they have their own. Whereas in the US, it's like European perspective is less relevant for the people here, but the ideas and the ways they approach it are super important as well to incorporate. So let's see what this Italian group did here, or what they're describing. AI-powered diagnostic pathology involves combining traditional histopathological techniques with computer-assisted AI technology. And there are a couple of steps in this process. We have generating whole slide digital images, which is usually the first step that everything is based on. Then we annotate and train algorithms. Sometimes you need more annotations, sometimes less. Now, with the foundation models, the tendency is to go towards less annotations, which is fantastic because you're avoiding a bottleneck. And then constructing robust data sets. That was a topic that was covered at the American College of Veterinary, ACVP, American College of Veterinary Pathologists annual meeting, where we had a separate talk on data sets, like how important are data sets, and giving people access, or like making it possible to access data sets to actually create these things. And by these things, I mean AI algorithms, AI models, digital pathology tools, create and test them. So that's also big picture consortium that's going to be addressing this. But data sets, like the keyword data sets, I think before listening to that talk, it was like in the back of my mind, and that talk by Christoph Bertram brought it to the front, like how important it is to benchmark your things, and now on a regular basis as well. And then obviously testing and monitoring consistency, and that's what data sets are going to be important for. Testing and monitoring consistency with clinical expectations, and validating results externally, and overseeing the output of algorithms. These steps need to adhere to quality standards and obviously ensure patient safety. And current evidence suggests, and this is a theme coming up over and over again in different papers, is that AI can enhance the accuracy of human diagnostics, enhance the workflow, basically kind of like supercharge you as a researcher, as a diagnostician, but it cannot replace humans as autonomous classifiers. There are attempts. I don't trust these attempts yet. I'm not gonna mention what kind of attempt. I'm just gonna tell you that I've recently heard about something in the veterinary space. Once the publication's out, I'm gonna tell you more about it, and let's see what they put in that publication. Anyway, so now we have generative intelligence that is promising us technological advancements. And when applying all these technologies, we need to adhere to international healthcare institutions' recommendations. And they recommend clearly defining the application domains and implementing and monitoring safety measures. So keyword application domain, right? It's not going to be one tool that solves everything. It's going to be something for a specific application, for intended use, for use case. Like all these words are going to be there. That's what it's going to be for, and not like, oh, one tool that solves all problems. I don't think any of you like believes that we will have one tool that solves all problems, even though ChatGPT is pretty powerful. And we need to focus on patient-centered safety considerations, and that requires the necessity of collaborative efforts among governments, academic institutions, international healthcare agencies, scientific societies, patient associations, algorithm developers. So like a bunch of different stakeholders. And when the podcast with Andrew Janowick goes out, you're going to hear more about that, like when they validated and deployed a digital pathology tool. All these people in one form or another were involved in working on deployment of this tool. On the creation of this tool, it was mostly algorithm developers and the pathologists that were helping to develop this tool. But then deployment, it was like representatives of a lot of departments, right? And one important thing that he said, Andrew said during this podcast, was that not a single person that is on the author list, and there's a long author list, can reproduce this work that they did on their own. And that is the trend that I'm seeing as well. That's something I was talking about at the ACVP meeting as well, that to ensure liable and reliable AI in whichever form or shape you are trying to build it, it's gonna not just be like the computer scientists. It's not just going to be the pathologists. It's going to be everyone working together, and that's how it's going to be. Especially legal, also IT, like people that you didn't think you will ever be working with based on your specialty. They're going to be your partners in this endeavor of providing reliable and liable AI. Oh, this one is so cool, guys. I love this. Voice prints of cognitive impairment. So that goes together with the first one that we had, that, well, we have to do histopathology postmortem, but actually we can listen to people while they are still alive and help with diagnosis. So before we dive into this one, I want to show you something. So there's a tool that I have, this thing for recording like voice notes and sometimes meetings. I mean, I have an AI recording my meetings most of the time anyway, but this is more like, okay, I was using it at the conference at SITC. We were having different discussions with potential podcast guests, potential partners, and in general, like brainstorming. And then I talk to it, right? So this is something that could potentially give me diagnostic insights if I was some kind of early onset Alzheimer's, which I don't think, no, there's nothing indicating that. But the point I'm trying to make, phone is listening to you. So like we have these tools that are basically listening to you. And this paper is the first time I am hearing about voice biomarkers, digital voice, analyzing digital voice for early detection of Alzheimer's. I love it. Like biomarkers in general, I come more from the tissue biomarker world, but in general, biomarkers of disease now with AI, probably like if you're typing, although now everything is going to voice, it could probably monitor your typing, and if you're declining, it could do that too. It's just me imagining all the possibilities, but let's dive into this paper. What they did here, this is a group from US, Mass General, California, different universities in California, and basically a long list of authors from the US. And here, early detection of Alzheimer's disease is critical yet challenging, particularly in younger individuals. I know younger, like not even yet retirement age individuals that are suffering from Alzheimer's. And I recently heard a story of a person that was 37 when they started being sick. So that's crazy to me, because in my mind it was like old people's disease, and no, not necessarily. So this study leverages AI to analyze voice recordings from craft story recall task. So this thing, craft story recall task, is a specific like neurocognitive task where you hear a story, then you are recalling it immediately. And then the next step is to recall it after 20 minutes. And they are checking, okay, how much did you remember? How much did you remember like verbatim, literally with the same words from the story? How much did you rephrase? And that's like an official neurocognitive test. So they did that. And there was this longitudinal longitudinal early onset Alzheimer disease study, and they used it to detect cognitive impairment and differentiate early onset AD from early onset non-AD cognitive impairment. And they used speech samples from 120 patients and 68 cognitively unimpaired controls. And they employed two classification approaches. First, feature engineered machine learning. So they already knew what they were looking for, and they could engineer these features. And then they had this end-to-end deep learning incorporating large language model. And they measured the performance, and to detect mild cognitive impairment, the feature engineered model, it was using acoustic and linguistic features, achieved AUC of 0.945 in the test set. Then the end-to-end deep learning model was slightly higher, 0.98, but both super high. And then for differentiation of early onset Alzheimer from early onset non-Alzheimer, the featured engineered model was AUC 0.8, and the end-to-end model was 0.9. So it was a bit better. And explainability analysis revealed reduced linguistic informativeness as a key Alzheimer's disease indicator. And I checked for you what this is. You basically simplify the way you speak. And it's like a feature. Sometimes you use it on purpose to communicate better, right? But if this is like a pattern in your speech in this specific craft story recall task, then this was indicator of Alzheimer's disease. I thought this was fantastic, and I'll have a lot of voice data, so I don't know if there ever is something I don't know, can you even on your own start getting worried about you getting Alzheimer's, or is it people in your surrounding that notice something that you're start repeating questions and things like that? Anyway, I do have this device. If anybody is interested in this, send me an email or send me a LinkedIn message. I'm going to send you the link to this. It supercharges your email writing, brainstorming, insights and things like that. It's called PlodPin. Okay, so we have this question. Application specialist in the field of cytogenetics, IHC fish, digital pathology for years. We often hear the demand of traditional fish will slowly go down with emerging optic genome mapping. Honestly, I cannot answer this question because I don't know the answer. But the trend I see in this is maybe there is going to be an easier method. And I don't know how optical genome mapping works, but basically what I see here is, okay, there's another method that's going to replace an older method, probably in some instances. But what I'm seeing also is that there's a lot of things happening in parallel and a lot of combinations of classical and new cutting edge. So either there's going to be a transition period or there is going to be things happening in parallel for longer. So again, who is not on my list, I'm going to give you another chance to join the list through the book. And we have one more paper. Let me check. I'm just going to send you what it is, how I use it, and I'll send you the affiliate link that I have for this. But I should make a video. Let me know in the comments if I'm supposed to make a video about that, how I use it to supercharge my productivity. I'm just exploring, so I supercharge my productivity maybe 4 times, 7 times. That's already enough times, right? Okay. Prognostic prediction in soft tissue sarcomas using deep learning and digital pathology of tumor and margin areas. And this one is pretty interesting, and I'm going to tell you why. This is a group from France, different institutions in France, and here they say the histological FNC-LCC. This is a French diagnostic body that is defining what these criteria are for prognostic factors in soft tissue sarcomas, and it relies on the differentiation of the tumor, mitotic figures, and necrosis, and this is supposed to be a prognostic factor, right? But it fails to fully capture high-risk patients. And this study aimed to develop and validate a deep learning model to predict metastatic relapse-free survival using digital H&E stained whole slide images. So here we are predicting MFS, metastatic relapse-free survival based on H&E. As it was a retrospective analysis and was conducted in 308 soft tissue sarcoma patients in 2 cancer centers, and there was a training cohort of 149 patients and 2 independent validation cohorts of 64 and 95 patients, and they used so-called multi-instance learning convolutional neural net, and they trained it on distinct tumor regions to distinct tumor region centers, periphery, and margins to optimize predictive performance. And they found out that models using tumor center and periphery or their combination were consistently associated with metastatic relapse-free survival, but not really the models incorporating margins. So they demonstrated less reliable associations. Why do I think this is important or interesting? Because here we're talking about a different type of tumor, soft tissue sarcoma. It's a mesenchymal tumor, and in epithelial tumors, for example, colorectal cancer, the tumor margin or tumor invasive front is like the battlefield for the things happening on the immune oncology front, right? You want to quantify things in the tumor margin. And here in this sarcoma, soft tissue sarcoma study, they showed that the margin is not that important, but periphery and center can help you predict things. And they confirmed that high-risk score from deep learning models were independent predictors of the MFS, and the deep learning CP, which is the center and periphery, outperformed their usual grading in prognostic accuracy. And tumor margin information did not improve predictions. So that was interesting. I thought that, you have different biology, different origin of the tumor, and different regions of the tumor are important. So now in the cloud of SITC and the immunofluorescence and biomarker, like very precise biomarker analysis, I would like to know, okay, what is expressed in these, in the margin versus the periphery versus the center, just like to learn about the biology. It's interesting because here they were working on this from H&E, and they have a result, right? They can predict metastatic relapse-free survival. And now the question is, why, how you can go to like higher plexing methods and check it, because you already know where to check, and that there is something happening. So I love like there is the synergy of methods, not one of the other, but one insight from AI on H&E leading into a potential to using something else. Other than that, next week we will not have our live stream because it's in the US, it's the Thanksgiving time. So people are going to be giving thanks, and I will give you thanks as well. First, offering you the book again. So if you're not on my list, you're going to get on my list when you get the book. And then you're going to be informed about everything, all the podcasts, all the, promotions, offers, what's new in the store. If you want to thank somebody with beautiful earrings, or buy them for Christmas. Then you do want to go to the store. I'm going to show you the code for the store as well. It's going to be in the corner. For me, it's the upper left. For you, I don't know. So today I have cartilage, but instead of my favorite multinucleated giant cell, come on, this is a multinucleated giant cell, my favorite type of cell. It's a bunch of macrophages together fusing. And then we also have we already showed these, and I have cartilage. So we have these. If you're on the list, there's going to be a little thank you, something coming in the email. So be on the lookout for that. New podcast coming out next week. And if you're not subscribed and you are watching this on YouTube, it would be fantastic if you could subscribe to the channel. That helps us grow, that helps us bring this digital pathology and medical AI message to more people, more researchers. And your support is so important, and it's making this whole work. So my trailblazers, you are amazing. Thank you so much for joining me today, and I talk to you in the next episode.